Hello.
Hello, sir. Good afternoon, sir. I'm Srilakshmi from Civil Department, faculty in Civil Department. Uh,
Good
so,
afternoon. Yeah.
good afternoon, sir. So, we're just waiting for a few minutes for people to join, and then we'll start, sir.
No, that's fine. I was just checking whether it's working or not. It's okay.
Yeah. So, you'll be presenting, right, the PPT, you'll be presenting, you're not sending it to us.
I can send afterwards, maybe.
Yeah, yeah, yeah. Yes, sir.
It's fine. Okay.
Thank you.
So, Lakshmi, how about we start now?
Yes, sir. We're just starting. Anamika is just starting now. I've just messaged her.
Okay.
Yes.
Okay, ma'am, I'll start now. Good afternoon, everyone. My name is Anamika Venu, and on behalf of the Skyline Association, I welcome you all to the second session of our Industrial Experts Lecture Series. The topic for today's session is Geotechniques, Key Foundation for Civil Engineers. And we are very pleased to have Mr. Raj Tilak with us today to give this talk. He is the principal geotechnical engineer at Worley Parsons, Dubai, and in his 22 years long career, he has worked on multi billion dollar prestigious projects in various countries across the Middle East and few other countries like India, UK, Netherlands, etc. His areas of expertise are seismic studies, oil and gas infrastructure, coastal facilities, marine structures, and of course, onshore and offshore geotechnical investigations. He pursued his bachelor's in civil engineering from Triple M Engineering College, Gorakhpur, and went on to receive master's in geotechnical engineering from IIT Kanpur. Also, he has had 7 publications in leading journals. Sir, it is our honor to have you as the speaker for today's session. Some of the topics that will be covered today are why geotechnical investigation is critical for projects, new developments in soil investigation and ground improvements, and finally, challenges involved in offshore renewable energy projects and onshore projects. Today's talk will surely provide a stepping stone to understand the key role of geotechnical investigation and foundation engineering. The speaker will be attending to questions at the end of the session. Any questions for the speaker are welcome to be posted in the messages section of this meeting. Without further ado, I would like to invite Mr. Raj Tilak to take over.
So I think you're on mute.
Okay, now let me present as well. Yeah, I'd like to thank you, Ms. Anamika, for introducing, and also Dr. Vivek and Hemant for arranging this presentation. Yes, I will be glad to teach some of the UG students. I was always keen for them to learn what is actually the industry practice and how it is way far different than what we generally learn in colleges. So I think the colleges do help a lot in aligning students to learn the learnings, but they cannot teach everything. So I appreciate the efforts by college in arranging such lectures and seminars to give you a glimpse of the future. So I thought of taking you to the future, to your office, and see how you understand how you will be actually doing your work at office and what would be your daily routine. I don't know whether I'll be able to cover all the topics that has been written in the email, but of course, I will try to see whatever I can cover. But the intent is to give you a glimpse of your future. So with this, welcome to your future. Like most of you are pursuing civil engineering, and I understand that you are probably third year and final year students, and probably you will be learning a bit of geotechnics at this point of time, but later on you will go on and do your masters and PhD in different expertise of civil engineering, and you will end up in these following sectors most of the time. You will be either catering to oil and gas, power plants, maybe ports and terminal, or some infrastructure projects, mostly popular in Dubai, buildings, and you will end up in sustainable energy, which is quite growing industry here now with solar parks and wind farms. So yes. Now these terminals or the sectors will are actually distributed in onshore and offshore, or it is a coastal, which we call as a near shore. So you are able to see my slides, right? Anamika, can you just confirm that?
No, no, sir.
No? Okay.
No, sir.
No. Okay. I thought okay, maybe I had to click one more. So excuse me for that because I am actually new to Google Meet. We typically use uh, Teams here. So this is what I was speaking to. You will be attending to these sectors mostly when you graduate and follow your dreams. So these sectors are distributed among typically onshore, offshore, and hello. Is it okay now? You can see that?
Yes, sir. Please continue, please.
Okay, fine. Okay, fine. Sorry for this goof up. And you already know that civil engineers would be further divided into various specialized disciplines. Of course, this is related to geotechniques, and then some who are not even doing master and PhD would still be a civil and structural specialists. And then you will see that there is a department called general civil later on in the industry, which is like specialists in underground, like utilities and corridors and all those stuff. And then, of course, there would be a discipline called transport, which will be designing the roads, pavement, highways, and all those things. And water hydraulics and environmental are also popular. Water is important in lots of aspects. It is generally used in all kind of oil and gas refineries, also for seawater intake structures and outfalls. So they deal with the water process. So I also wanted to let you understand that you will coordinate with each other a lot. It's not that you have done geotechnics, so you need not understand what structures does and how your inputs are seen by structures or in fact other disciplines. How piping guy or a mechanical guy is you will use your data. So this is where your coordination and your knowledge of other discipline is very important. You may already be taking some courses of other disciplines, but when you come to the job sector, you will basically interact a lot with them and you will gain and provide input to them. In the office setup, how it works, typically you will either land up in an owner company, which is the like a client, ultimate client, or you will be a consultant who will be giving consultancy to the owner. Uh, So these are the terms which will be used in your near future. So I thought you should be aware of how these terminologies are used. What is a consultant and what is a contractor? Contractor is the guy who executes the job, and it's not typically the consultant. Consultant may oversee the contractor's job, and contractors, mega contractors, do not do all the jobs by themselves. Like if you're trying to build a house, the contract which a bigger contractor will take is of the entire building, but he will still offload some of the jobs to a subcontractor. It could be an electrical work or a plumbing work or any other work. So similarly, there are lots of subcontractors who would be servicing the contractor, and each one is client of the other. So some contractor will have a client like contractor, and contractor will have a client consultant, and then we will have a owner company as the ultimate client who is actually shelling out the money for the works. Uh, so how the geotechnical workflow happens, like what you actually do in geotechnical engineering. Probably you all know that you will do some investigation and then finally you will produce some kind of report. So we start on a given site by understanding what is the historical data available. We will probably do a desktop study in the beginning, and then desktop study would be targeting the end use. It's just not a desktop study. It is with the objective of what would be the end of what end use of that particular study. Then you plan your investigations. You see, it is quite resembling with how doctors work, where they take your medical history and then they give the prescription, and this is what geotechnical investigation plan is. You prepare a scope of work and specifications, and the work will be done as per that. So this is where your key role is very important, and you will have to understand what is the end use of that particular planning that you are doing. And then finally, what you will do is you will award the contract to the GI subcontractor. This is the contractor who will actually do the investigations in the field, and you may go and supervise the work or see whether things are done as per your specifications. So this is how you will do the execution of the geotechnical investigations. At the end, you will produce an interpretive report which is like doctors, when you have got results of all your blood tests and all pathological tests, you will look into it and then you will find out what the disease is, and you may have to propose a remedy. Remedy here is the type of foundation that you are going to propose. It could be a shallow foundation, it could be a piles, or it could be a surgery type of thing, which could be like ground improvement works, where you actually do something within the earth. And the job does not end here. People do understand that the geotechniques, once the report is available, their job is done in a project. It doesn't happen nowadays like that. You have to be there to support in the constructability of a particular scheme, and you will be supporting when the piling work is going on as per whatever recommendations you had made, or even the ground improvement if you have suggested. So your report does not, your role does not end here as geotechnical engineer. It continues, and I have seen these changes happening, and most of the time in old days, once you produce your geotechnical report, and your job was considered to be done. So one other thing is geotechnical investigations done only once for a site, and is that it, or or do we continue investigating? So it actually starts from the concept stage. Like suppose you are trying to build, let's say, take case of Dubai. We have a lot of artificial islands built in the Gulf, which is primarily replacing the all offshore structures because of longevity and durability and of course the mobility and the longer life span of these structures. So once you are deciding that you will come up with an artificial island, or let's say even offshore structure, where will you place it? In the sea. So this is the concept stage where you decide based on the requirements how many of the islands or how many offshore jackets or even the onshore refinery, where should it be located? Is this site suitable for constructing a refinery? So for such cases, lots of GIs are done. Maybe very limited, but still a GI is done. This is called a concept stage. I have highlighted few terms here in capital because these are the terms which will be used in industry. And you will fumble when you are not aware of that, like what are these terms. So concept is the original work when you do not know where the actual plant is going to sit. Feed stage is once you have decided that, okay, this is the location of a particular plant, and you this the full form is front end engineering and design. So this is actually the tender package. The guys who are working to develop this tender package is called field engineering or front end engineering. So this is done, and then finally you will produce a tender document to give a feel to the contractor what he's going to face at site in terms of soil. You do a GI investigations, and this is called a feed GI, and then you include it within the tender package so that the contractor who is bidding for it, he knows whether he is bidding for a shallow foundation type of structures, which is less costly, or he will ultimately land up in piles, which is a huge cost, and nearly a greater share of the overall project cost is shared by the piles. Let's say for a typical refinery, it would be 15 or 20,000 piles, which is good enough a cost as compared to normal concreting and shallow foundations. Or if he had to go for a ground improvement, that is an additional cost. So while he's bidding for the job, he is called a bidder. So bidders are the guys who are bidding for a job, taking some tender into consideration. They are called contractors when they win that job. So when they win that job because of their technical and commercial viability, so that is when they execute this job, and this is called the execution stage. So the contractor now performs another GI, which is called a verification GI. So he just wants to confirm that whatever data was provided in the tender or a feed stage, that is it, and he will not expect any variations in the soil. So he can comfortably go ahead with design. In addition, contractor does a much more detailed survey as compared to what is provided in feed, because he has to design lot many structures other than just having a feel of the soil. He has to design machine foundations. He may have to design a long vertical columns. and very tall chimneys or something of that sort. So he will have to do a lot of other design things, which for which he will get input from the GIs, his own GI. Now here is the trick. What happens if the feed GI report was not comprehensive and not adequate, and contractor got misled by the information provided in the contract? And when he did his survey, he sees a lot of variations and difference. And this is where huge claims, and this is huge means really huge, it could be of any order. I have taken up some project examples here without naming any project because of the confidentiality, but I will just give you a hint of it. What happens if there is a difference? This is just fun fact that geotechnical is not limited to geotechnical engineering. If you know Carl Terzaghi, he was the father of soil mechanics, and he's a mechanical engineer. And he's not civil engineer at all, and he's the father of soil mechanics. He had interest in geology though. The other aerospace scientist, Prantl, he is his NC and NQ gamma, which is typically used in bearing capacity. He had a big hand in giving those parameters. In fact, he was doing a research on penetration of bullet in the body of the aircraft, and this is where he found that he needs certain correlations to find out how much the bullet will penetrate into the body of the aircraft. So these are the guys out of geotechnics, nothing to do with geotechnics, but they gave you a lot of philosophies in civil engineering in general. Like even he's got some contributions in piles, and he has also given you some bearing capacity formula. But still, failures do happen. In spite of all this, nature is still strong. You can't design what you can design. So there is always a limit given to you to have a boundary. Like you cannot design for an earthquake which is going to happen in 1,000 years. And if it happens, so there is a probability of occurring of earthquake. And if it happens, so do you actually spend so much of money on designing certain thing which has got a probability of say 1%? So these are the things that still happen because of certain limitations during execution, either for the cost or being too uneconomical. You cannot have a very high beam sizes or column sizes just because something is going to occur with a very least probability. So these are agreed in advance, and these are provided within the feed document. What is the boundary against which the contractor will design his whole of engineering? You know that there are lots of instances where there are cavities. You might have heard stories of sinkholes in America, and it's not very uncommon in this region as well, though you don't see something disappearing. But when you do investigations in Qatar, you do find that there are lots of cavities within the limestone layer, which is not seen from above. You see a cave drawn here. So this is what happens in reality. Pisa Tower, everybody knows it. This is a classic case of differential settlement. Nothing to discuss about it. So failures do happen either because of a long-term settlement. You had a road matching with the plinth of the building, but suddenly you see after 10 years your building has gone down. So you need to provide now stairs to go inside the house or provide a ramp, whatever it is. So these things do happen in life. I know this is what your course covers. Typically, you would be learning about bearing capacity and settlement for the shallow foundations. You will be learning about piles, maybe earth retaining structures, embankments, some bit of machine foundation. You will be touching upon seismicity as well. To what extent, I'm not sure, but probably up to liquefaction studies, you will definitely be covering. And you will be told a little bit about ground improvement techniques. And this is what you will be taught. But other than this, what I feel that you should be aware of is there are lots of standards and codes which actually are used in field if you are working away from India. So you may need to know these codes. I don't want here to highlight that they go through each of the codes, but at least know that there are lots of codes available, and it's not only Euro codes or ASTMs. There are lots of Syria codes, which is construction industry practice. And there are for typically for seismicity, people use IBC, and of course ICE is one of the codes for UK. And mind it, these ASTMs and BS codes, when they refer certain tests that may not necessarily be catering to the Gulf environment. So there are other known textbooks and other references where you should look into it, that when you do your interpretation, you know that the results here cannot be utilized in as it is condition. You either need to test it differently other than what BS or ASTM say, or you need to have your own interpretation based on the values that these other references would provide. Some companies means the owners, have their specific codes, and you may need to follow that, or they could be a country specific, like in Russia. You cannot rely on BS and ESTMs and Euro codes. There is a whole set of GHOST and ISNIT codes that you need to follow. Similarly, for Algeria, it could be a French code which is popular there. Similarly, like even in Eurocodes, you probably would know that there are lots of national annexes which are attached to the main body, and each annex is offered by different country differently because they follow certain things in a different way. But saying this, it does not mean that whatever structures were designed based on original BS codes is no more relevant. Because Eurocode has introduced a partial safety factors or something like that, that is something kind of an optimization going on, and wanting people to work in a particular way, but it does not rule out that whatever you had done in the past or we had done in the past is of no significance. I wanted also to introduce you to certain softwares. I don't know how much you would be having in your school, but typically you should be aware of, so that when you land up, you know, like these are the popular softwares, and these is what you require to have your run-of-the-mill business. Plaxis is one such numerical modeling software. You could be using some different software as well, but these are the industry popular softwares. It's not that I'm saying that these are the only ones. There are a lot of alternatives available to these softwares, but these are what is typically followed. Similarly, for lateral pile analysis, LPile is the most popular, and for settlement analysis, we do Settle 3D. You can still follow your Excel sheets, and these are not going to deviate too much from what these software give. But sometimes in complex scenarios, your Excel sheets are having a limited use, and this is where this kind of softwares kick in. Similarly, for sheet pile walls or retaining walls, you need Wallop, and there are all other software for ScopeW and GRV for pile drivability in offshore conditions. So just be aware of there are certain software which will ease out your effort in the future. You don't need to calculate everything by hand and when you're in school, but the basics are set in school. So even if you are using this software, be sure if you do not know the basics, it will be garbage in and garbage out. You will not be able to interpret what the output is if your basics are not correct. So when you're doing a SOAP W, you should know like which method you are using and why you're using, and what is the advantage of using a particular method, because software will do it for you, but the interpretation and the inputs are by you. So be assured that your basics, whatever you are learning, is of great use. There is a lot of debate whether geotechnics is an art or science, or is it really engineering, because it does not follow 3 decimals of precisions like what other engineers get. Like if you're doing a structural analysis, and you somebody asks about your utilization ratio, you say it's 0.9765 types, or maybe 0.8735 types. So here the problem is that these materials are quite variable in nature. These are not man-made materials like steel and concrete. So that is one challenge that you have to face. There are lots of uncertainties involved. Even if you have done, you're still not sure that you have actually mapped the entire site. There would be still surprises. That is why we do a lot of field and supplemented by the laboratory tests. Field, whenever you're doing testing, there are chances of certain disturbances. So each one has a plus and minus. So that's why you have to take many tests to come up even with a single parameter. One thing is there for sure, even if you're doing field test, one type of test, you still get a lot of scatter. You will have to understand that this is natural, and you will have to come up certain design parameters. So these are the challenges. Even chemical compositions, how much corrosive it is for the concrete, because at the end of the day, you will have to recommend the type of concrete that other engineer should be using it. And keep in mind that your soil parameters that you recommend is not fixed. It may change based on the end use. If your rock is very fractured and you want to take into design, probably you like to see it as a very weathered rock type, so that you take conservative, and when you're recommending bearing capacity or when you're having a pile capacity, you have some margins in your hand. But at the same time, if it is a water flow situation where you're analyzing, trying to analyze seepage, this weathered is going to not help you. Then the conservatism thing becomes just the opposite. Probably you will have to think that the rock is intact and there's very less water inflow, and then you'll have to suck more water out of it, and how to do it. So these parameters do change. So don't treat that this is the final design parameters. And of course, experience and judgment do take place, because if you're testing a rock, and you found the strength of the rock is varying from zero point 0.5 GPa to say 5 GPa. So when somebody asks you to recommend certain parameters, this is where your experience and judgment counts. So do take help of your seniors when you are starting the industry. Then probably you will get comfortable and you will start taking judgments. This is one point which I just wanted to highlight here, that it's no more a standalone geotechnical discipline working in its own shell. There's a lot of times where your interaction with the structures is required, and it's always to and fro. You give an input to the structures, and structures analyze and does their analysis, and they come back that this is what they are getting. Then you say, no, this probably you need to modify this. So you update your parameter to get back into his input. So there is a cyclic process involved till you both of the outputs match, and then you are happy that this is safe. You also need to know that how your data that you are recommending is used by other disciplines. Maybe the pipeline guy is using for some probably corrosion of the steel pipes, while the electrical guy and the instrumentation guy are using the thermal nature of the soil for their thickness of the cable or the protective layer that have to provide over the cable. So there are many things where they come into picture. So you should be aware like how they are going to use it. And this is where you can plan what you need to plan for the GI. If you do not know the end use, and you thought only the end product is just a shallow foundation or pile, no, at times it is not. So be careful of this. And one thing other than this, what is happening is that we used to have a global factor of safety approach long back, when you used to arrive allowable bearing capacity, you use effective safety 3. Even in piles, when you calculate your ultimate capacity, you divide by 3 to get the your allowable. Now it is not no more the case. Now it is more a limit state approach. You have to do what is specified in Euro codes, ULS and SLS both, and you have to use partial factors, so that the structures guys who are doing the limit state, it matches with your limit stage, and he can understand what you have done, and the vice versa. So this is how Eurocode is trying to align the geotech structures together. The last point probably I've already said, that it is still safe, whatever you've done. Don't worry about that. It's just a different way of doing things. It's not that these things are wrong. Okay. Regarding the test type, what you typically do in the geotechnical investigation campaigns, and what are the tests typically you do when you are trying to do a foundation design for either a spread footing or a piles or a machine footings, machine foundations or retaining structures, even for slope stability. So right inside you see the common kind of tests that we do. We plan boreholes, we plan CPTs, depending on the whether it's more clay or more sandy. So you decide either you need both of them or you need one of them, and it's good enough. But one thing when you're doing GI, you do not know whether you will end up with piles or you will end up with spread footing. So you will have to keep some provisional boreholes with longer depths, so that you know if it is concluded that piles would be required, so you still have sufficient data. you cannot go back and remobilize the subcontractor to get the additional GI. So you plan accordingly in advance. You try to understand what the end use is, and you recommend accordingly your test campaign through your scope of work and specifications. Somewhere groundwater table does play a lot, so you should try to install few piezometers in the ground, because boreholes do measure the groundwater tables, but it is not very precise. It can have the drilling fluid inside, so there are sometimes differences observed. So sometimes we recommend to put some piezometers. Trial pits is just an open excavation to see the soil, especially useful for the shallow foundations. And some density test and clay glue test, these are actually useful for the earthworks, and of course to verify whatever you are recommending, you are actually not way off by doing some field tests when you estimate and you do your calculations. For machine foundations and even for the seismic parameters, when you are recommending for the soil type, for structural guys to find out how much lateral forces they are going to see on their structure because of earthquake, you need to do some seismic downhole or crosshole tests. So these are typically all codes recommend that to have a proper ground classification, you need to have a 30 meters of soil data. So keep in mind, if somebody says that he will do a 15 meter of seismic downhole, uh, not a standard consultant will agree to it. Okay, similarly for pipelines, you need to do some trial pits. Pipelines do have some stations, they call it block wall stations, etc. So sometimes they do have some structures. Pipelines could be running kilometers and kilometers. You cannot have so much of GI. So you try to minimize and optimize. So you do boreholes only at the stations and probably a few in the route of the pipeline. And you need some electrical history for the cathodic protection design. For payment, typically CBR and DCPT are the input parameters for the highway engineers to design. Payment typically does not come in isolation. It is associated with bridges and other river crossings and some wadi crossings in this country. So you will still have to do some basic tests other than CBR and DCPT. You still need some boreholes, etc. Maybe there is a bridge coming in. So these are typically what is used, as this is just a guideline for you. And then you will have to probably explore some special objectives. Maybe there is a soil which is like swelling or collapsible on either increase or decrease of the moisture. So your structure needs to be designed for that. But for that, you should know what is the swelling potential of the soil, or how much the soil could be collapsed if there is a water ingress. So you have to take measures accordingly, whether you do not allow water to go into the soil at all. Like it could be for many countries where it is like desert-like environment, like in Sahara Desert, and if there is some gathering station or soil oil stations, you need to see what is the impact of water, because they don't typically see so much of water, so they can behave differently. Similarly, you may be landing up in permafrost regions in Russian countries where you need to find out what is the temperature variation, or what is the effect of ambient temperature on the soil. So you may have to do all these kind of special investigations. Similarly, for geological risks, you have sometimes to find out cavities and faults. Uh, you may have to do geophysical tests for that, which is not covered here at the moment, but that is what you need to do. Even for ground improvement, there are a lot of tests other than borehole CPT, which is typically done not as a routine, but these are the pressure meter tests and zone tests done in the field. Uh, it is also used sometimes for the rocks as well, the pressure meter test and dilatometer tests. So these are also some tests which are done. This is it. This is for the investigations. Now I'll just touch up the very basic of it. I don't think I'll cover everything, but for at least for the bearing capacity of a shallow foundations, probably you already are aware by now that this is your standard equations. Ignore all the factors and inclination and blah blah other factors. But this is the basic equation that you have. You may have other forms as well, but in this, if you look at it, you have a particular failure profile when you load a footing, which is shown in black color, and the soil failure pattern through which this parameters NQ and gamma are derived from. So these are just not an empirical relations coming out of nowhere. These are mathematically derived by having the failure pattern of the soil below, and there's a particular shape, and different authors have assumed different shapes. So that's why you see a variation in the recommendations of the NC, NQ, and gamma by different authors. You can do by 2 or 3 methods to find out what is the ultimate bearing capacity, and then either you can take an average, or you feel that no, maybe you had seen some poor soil somewhere within the same site, so you should be going slight conservative. So these are the decisions that you take. But one of the questions that of course I see the people challenging is that the factor of safety of 3 that we use to arrive at allowable bearing capacity. What does that mean? Is it just the variability which is there, because of which we are feeling not so confident and we are using a very high factor of safety 3, while none of the other guys in the structures engineering use anything more than 1.15 or 1. Maximum 1.5 types. Even in load combination, it is 1.6 times something. So why 3? So just let be aware that 3 is not actually for the that much related to uncertainty, because bearing capacity is not what this equation gives. You have the other criteria settlement in place, because this settlement will allow how much you should be allowing your structure to be loaded or the foundation to be loaded. If you have a criteria of 10 mm, which is sometimes the case if the crane of a class 1 type is running over it, then your bearing capacity may come out much less than what you have calculated by this above equation, because your settlement is limited. So you will have to use a combination of these two and decide what is the allowable bearing capacity. So a factor of safety 3 is to bring you very close to the 25 mm of settlement figure, because that is what is typically followed. But if you have a allowable settlement of 50 mm, you can have much more bearing capacity, allowable bearing capacity. So that is what the intent is. But really, is this the case that you actually have all the time? No. When somebody asks that, okay, your foundation is placed in a seismic zone, so there is additional forces acting on this failure soil mass assumed below. So how does NQ, NC, NQ, and gamma, the bearing capacity factors, change? It does get modified, because these NC, NQ, gamma has been worked out on the principle of equilibrium of forces between different zones 1, 2, and 3. So if you introduced a seismic force into that, the equilibrium will change. So your NC, NQ, gamma will change. So enough of C5 and all those things, input parameters given, and you calculated the bearing capacity. But in field, you will never be told what is C and phi. This is what you will get. You will get either a borehole log, which is called sometimes a boring log, because it's really very boring. And sometimes you get something like ECG of the heart, which is of the soil here, which is called CPT profile. You may have to interpret these data to find out what is your C, what is your phi, and what are other parameters. You won't get C and phi as you will get in your textbooks that this is C and phi, and find out the bearing capacity. Our professors had thrown us this borehole log, and we were actually troubled like what to do with this. So be prepared for this. There would be such long reports coming to you, because some third party guy would have done this report, and you will have to now provide recommendations. So lot of settlements and lot of correlations you will have to use to find out between the SPT values given or the CPT values given what would be your C and phi. So that's why a lot of correlations are available, and that will help. But even then, you have got all those C phi and everything. What if your foundation is actually very close to the slope? Does your failure pattern still complete that full circle that they were drawing? It may not. Even the gamma D, the surcharge over it, is not uniformly available to resist soil from failing. You may end up in this case. You may end up in a case where you have a hard stratum below, and then your failure pattern is not the same as what was envisaged with a semi-infinite mass that we learn. So these things will trouble you in future, and probably you will have to go back to multiple books. These topics are covered in several other books. Maybe you will have to find out references. It's not that these conditions are known. These conditions are known that will happen in the field. But just going by one book won't help you. That if you know the formula and that is it. Because I have seen with my juniors and I see what they have been taught and hey, how much struggle they have to do when I pose such questions to them. So be aware that these references are available. It's not that it is not. Similarly, like case where you have a stronger soil at the top, this is very common, and you have a weaker soil at the bottom. Your project manager will go to the site and see the site, and he will see a very strong soil at the top, and he would just probably stamp his feet or maybe take a rod and punch through. It's a very good soil, and he's happy, and he sees that, yeah, this is a very good soil. We should go ahead. But then when you look at the borehole logs and you see that there's weaker soil here, then what do you do? How do you come up that this is not going to work? You will have to use much more less bearing capacity as compared to what is typically recommended. And he will not be ready because his cost will go up. So you should be able to analyze all these things. There had been an instance where I had to recommend piles, even though the top 4 or 5 meters looked perfectly all right. So it was a big challenge. So these things do happen. Like for this foundation near the slope, I just wanted to highlight how it happens in one case just after the slide. This is how typically a geotechnical report recommendation on bearing capacity looks like. Forget about the language, etc., because this has been taken from Netherlands. But you look, they have a footing width and length, and maybe this is all for square footings. And the last one you see for the strip where the 0.6 is the width and the length is probably 4 meters. And then these are the recommended values of bearing capacity at different depths. So if the expected loading on the footing is more, you may have to go either at deeper depths or you may have to widen your foundation. But note here one thing that the my red circle is at the wrong place. Sorry for that. H is equal to 0, something which is written here, because when the geotechnical report was provided, probably at the beginning of the project, the guy did not know what is the horizontal force coming on the foundation, and it's impossible to know because these things are known only when some engineering calculations are done and then only the data is available. So when this H is going to increase, I mean the horizontal force or its angle is going to come into picture, these parameters would change. That is why he has put a caveat here that this is all for H is equal to 0. So now you will have to go back and calculate the revised bearing capacity based on the inclination factors of the load and other factors that come into picture. I don't know whether you can see this is a pipe rack foundation just on top of the embankment. And if you see on the right hand side, there's actually a slope down. So this is the top of the embankment and this foundation is there. Probably the bearing capacity was not estimated properly, and you see the foundation has settled, and all these things you see is actually temporary measures to lift it up so that they can rectify this foundation. So this foundation has started settling because of that. So these things do happen at site. Be careful, and just by saying bearing capacity this much, don't go it blindly. This is a message for our civil and structural engineers who will not follow geotechniques as well, but they should be aware that such situations do arise. Similarly, one of the classic cases of the soil classification. It's a very boring chapter probably. Nobody tries to stay focused on this chapter, like why so much of classification systems are available. What is the end use of this? How does it matter? Well, you know that it does matter, but how much more it can matter is something which is to be known here. Typically, soil classification, when you're doing it, it is that you are trying to standardize it the way you define and the way the other guy is going to understand. So it is a kind of a standardization thing. You may follow certain method, certain code to do that, but then just specify that this is what you have followed so that he can follow the same code. And this is most important for the earthwork as well, because your all compaction techniques is dependent on the soil type that is to be compacted. You will see it in the coming slides when I talk about ground improvement. That is how important it becomes. There are billions of dollars which are claimed by contractors where owner said that this ground could be, used for earthworks. Because when you get the ground or the site, it may have undulations. And you want to just balance cut and fill, and you want to cut certain areas and use the same soil into the filled areas. Sometimes because of the process requirements, something needs to be at higher elevation. Because of that, also cutting, filling, and terracing is done on the sites. So this earthworks sometimes is done by the owner himself, which is called an early works contract, or sometimes it is passed on to the contractor. So when you pass it on to the contractor, you are told that okay, this soil is good, you can use it. And when once you go outside and you find no, it's not suitable for compaction, and you will have to import the extra suitable material from somewhere far off. There's a cost associated to that. So there are a lot of times where these things happen. So please do concentrate on that to be just keeping aligned with what other people understand. What happens if the feed GI was not adequate, as I was referring in my initial slides, or something changed later on? Like if you look at this one, the red circles that you see is what was the tank locations in the feed. And during the feed process itself, so if this was the tank location, the GI was done based on the locations of these tanks. They did this GI fine. But later on, because of some other process requirements, these tanks were proposed to be shifted, something on the north and something on the south. And you can see that there's no red spot, these pink spot, these are the GIs. There's no red spot on the north side, and similarly on the right hand side, you can see there's no additional data. So here, it's a clear case of extra claim where the contractor will use it for its benefit if there is a change. The other drawback was that I wanted to pose this question, but because we are like a YouTube channel type thing happening, but I wanted to ask, like, if the B is, let's say, 40 meters, the tank width, and the tank width is, let's say, 100 meters, what is the guideline typically used to recommend the depth of investigation? As a thumb rule, people do follow 1.5 times B, but it does happen that you have a very wide foundation or a very large tire tank, but the height may be small. So just look into it. What is the typical depth of investigation that should be done? Here, in this case, it was not done. So this is why I'm trying to highlight here. Here, the depth of investigation, even for 50, 60 meters dia tank, was just 1.5, no, 15 meters or 20 meters, with very few going to 30 meters type. While the tank sizes, though it looks very small in here, but these are probably, I mean, especially on the right hand side that you see, I don't know whether I have them. These ones that you see here, on the right hand side, these are 106 meter diameter tanks. So these are larger tanks. And continuing on the tanks, on single lines, if you look at the foundation of the tank, which is shown here on the right hand side top figure, it is a crushed gravel foundation type proposed. It can have this type. It can have a concrete ring foundation. It can have different methods and different ways of resting the tank on. In this case, it was this one. But you see there is a kind of a horizontal plate. I don't know whether I can bring it. Okay. This plate. This is called annular plate, and this is placed first, as you see from this picture here, and over which you erect the tank. First course, and then you raise this particular thing up, and then you put another layer from the bottom. So next layer will come from the bottom. So it keeps on coming this way, and then the tank goes up. Here, the material here, it was sand, not very unconventional, but the sand was probably to do with the cathodic protection thing, which was coming here as this dark line that you see here. So there was a requirement, but what happened that during construction itself, the annular plate started getting tilted, is in this way. So we were called in, and then we looked into it, and we did a lot of analysis to find out what could be the best remedy for this case. But in any case, whatever we did, that whole tank had to be lifted up to rectify the foundation. So the whole tank, which is like there were six tanks, and all of them had to be lifted up. The figure that I show is only for the initial concept, but the tanks were nearly 95% complete. So the complete 20-25 meters tank was lifted in air. You see on the right hand side bottom picture, and this whole annular plate was lifted. And just imagine the number of crew required to lift this tank in one piece. So there are complications involved. So be aware, and for the guys who are interested in design and engineering, uh, you can decide what model should be best if you're analyzing in Plaxis, whether 2D or 3D. Uh, you can see that I probably had adopted 2D. Why not 3D? Because if you look at the tank size, it's too much, and probably I am just analyzing a section of it, and it's a plain strain case for the foundations. So this is the amount of tilt that I got with the given loading terminal conditions. So it was definitely a case of a mix of construction flaws, the sequence of construction, and of course some bit of design flaws as well, because you cannot recommend something because this design is coming from somewhere and given in a country where which is not popular. So they do mistakes, and it is very difficult to say that the quality was not guaranteed and blah blah. But you need to focus like what is the country where and what is the regular practice in that country, and you should design accordingly. So now there's a huge cost lifting of the tanks. I don't know how many $1 million the contractor had to spend to lift it up, and this is not going to be claimed, and he cannot claim that. But it is a huge contractor's cost. Somebody's mistake. One of the reasons was there was no geotech engineer in this project involved right from the word go. Whatever came from the design office to the contractor, he just continued on that. Now, something on soil, where there's a lot of engagement of geotechnical people in this one when it comes to dredging, reclamation, and ground improvement. Probably you will not get exposed to these things in your UG classes, but you should know because it's all concept of soil only. There's nothing great coming in. We had a reclamation to be done in the sea for an oil export terminal. It is quite big. Don't go by the picture size. I had to fit in a lot of pictures here. And there was a dredging plant, which is like you will dredge this here so that higher or deeper depth ships can come to the close to the shore. And there are two jetties that you can see basically for these are pile jetties. So and dredging was this whole region to be dredged for the ships to come this way. So how do we construct it? The water depths here in the sea, it is sea. Probably you can say 0 or 1 here at the root of this whole structure, and it goes to minus 10 or 11 in the distant place as you move away from the coast. So you see, I just wanted to give you a case example here just to know that how much engagement of geotechnics is involved when it comes to dredging, reclamation, and ground improvement. The first thing was decided that this will be constructed in dry. We don't want to work in wet in the sea because there is a better quality control when you are doing things in dry as compared to you rely on divers all the time going and inspecting things. So this is how it does. So we had to build a bund here all around. This structure was already there. This is called a breakwater, which was already there. So we had to just attach our reclamation besides it. So this is, if you see the figure number 2, so there is a reclamation bund, which is having enclosed seawater as well there. And we did reclamation on the reclamation side. And what we did later on, we dewatered the sea part first within that area, and then we continued with the dry excavation and went around 20 meters deep, which is a bit of glimpse you will get in picture number 5, that how deep we went looking at the sizes. So yeah, so this is how the whole of the seawater was dewatered, and we went into dry to construct this block key wall. This is called key wall, just in case. And the compaction was done through rapid impact compaction for the reclamation area. And once this was completed, then you have to again, flood it back. So you can see in picture 6 that you, through siphoning, the water was again tried to flow in back inside the pits. and then the bunds were removed. And you see that the pile jetty, every jetty, the piling, everything was done from the ground. Now these piles are basically a steel pile, as you see the projected portion, but it is rock socketed below the ground, which is seen here. And imagine building a raker pile from the ground and having something connected at the top with perfect alignment. So when you do from the top, it's much more easier because your top structures is aligned. But here you are constructing something from the bottom and you are expecting it to align properly at the top. So there are challenges that you will face. On the bottom side, it's just a LiDAR survey of the picture, which now iPhone 12 has introduced in their models. But this is what it is. It looks like if you take a picture from the drone through a LiDAR survey, and you can see the dry excavation part, and you can see some of the reclamation part, and some of the areas which are still not reclaimed. This is still to be reclaimed types. So this is during construction and the progress was done through LiDAR surveys. Something on dredging, little bit of dredging, like, okay, you knew that we had to dredge this. The first question comes to your mind, which people will ask, like, okay, can we use this material which you are dredging into the reclamation? Is it good or is it bad? Or do we need to throw it away? If it needs to be thrown away, where to throw away? Can it not be utilized? So you will be posed with such challenges, and you need to address to them what to be done, because your ground improvement technique would depend on the type of soil that you see. So so when you are doing such reclamation in huge volumes, probably you need a borrow area from where you will bring the soil to reclaim this land. So what we you see is the typical dredger here on the top, the boat types, and how it works is that they dredge through a suction thing here. They suck the sand from here and it goes into the top, and then it is transferred to the hopper through a pipeline, and this hopper keeps on changing, going to the dredger section and coming back, and supplying the slurry of the dredge material into here, the reclamation area. You see, through a pipeline, this is supplied, and then your various excavators and these kind of equipments try to spread the reclamation, and then later on you will come back and do compaction on that one. So suitability of material, again, the same thing, the soil classification and the fines content that it has, the plastic index. So there are a lot of things that will come into it. Okay, bit of ground improvement techniques. I mean, I probably have listed many of the ground improvement techniques. Some of them are called reinforcement. Again, you can compare with the doctor where you provide a steel plate when you want to repair the bone. So yes, you provide soil nails, piles, or dynamic replacement, vibro replacement. There are many methods which are called, which come under the category of reinforcement. Then someone is improvement, where we do not bring an external source. You just do it on the available soil, and then you just compact it. There will be different methods of compaction. One could be dynamic compaction. The pictures on your center, I think this one. You see there's a huge mass lifted and then just thrown back, and there's a crater formed here, and you keep on forming craters like this. So this will compact, and then later on you will have to come back and level the ground. Similarly, for vibro compaction, you see there is a vibro float, which is this picture. You insert it inside by some pressure, air pressure or water pressure, and you create a cavity, and either you replace with the external material, then it will call vibro replacement. If you don't replace it by external material, you replace by the same material, then it is same, I mean, vibro compaction only. They have got limits and methods when to follow, what to follow, but the ones that I've highlighted in bold are the most preferred practice. Of course, it depends on the type of soil and the conditions where you get into, but what I see most of the times, these are the ones which are preferred. What? Anyway. So now this is a summary, more or less, like what type of ground improvement should be used depending on the soil type. Like if you have clay and silts, what options do you have under this category? And if you are on the sand level, what options do you have in this category? And if you are in rock and other materials, what options do you have? Typically, let's talk of sand and clay. Now, depending on the depth of treatment, do you require to treat only 5 meters or 10 meters? So your selection technique will depend on this kind of a guideline that we have summed up here. So there are many methods. Like if it is a clay, just compacting by hammering it down won't work because it will generate huge pore pressures. So you need to create a cavity and replace it by granular material, just like stone columns. Here, stone columns is also listed down here because that can work for deeper depths, while dynamic replacement, something you're tamping from the top and replacing, it has got limited depth of treatment. If it was for sand and gravel, typically dynamic compaction is used, and for deeper depths, you use vibro compaction. This can go to much deeper depths, so that is why it is shown here. There is a limitation that this technique cannot work here in clay and silt, so it has to work only in sand and gravels. While dynamic compaction can be used here with little higher contents. So there are a few play around in this one, but this is just to give you a guideline. So, okay, I mean, probably you will learn about ground improvement techniques, but how it is done in the field? How do you verify that whatever you have done is actually um, done to the perfection or the target criteria that you had set? So whenever when you prepare RFQ or a quotation for a subcontractor to let this ground improvement technique guy to come and do it, you need to give him a verification criteria. Like how will you verify it? Because he cannot just say and just have few roller passes and say the job is done. So you need to specify some target criteria, and this is typically called performance specifications. So so the ground improvement comes, and it's not that he can design everything on paper and he will be happy. He has some design tools, but finally he will come and do a trial compaction. And once he has done a trial compaction, by varying the spacing of the compaction points or checking that how much influence it has on compaction, what depth it can reach, and then he will do some settlement estimated, whatever he had estimated in the past and what is actually observed. Then he will come up with an optimal number that, okay, this height of fall, this much hammer, this much grid spacing, he will adopt. So once he does that, but then how will you know, I mean, that he has achieved that? To satisfy you, he will do some calculations. He will do some finally some again a GI consisting of basically mostly CPTs, where he will measure the cone resistances. He may adopt pressure meter test if it is all sandy. It depends on what type of soil he's compacting, or he can also revert to with you within SPT values or doing a borehole log, and he will give you all the calculations to tell you that okay, whatever method and whatever you specified, we have achieved that. One thing probably which we can cover later on is the CPTs, how they work for carbonate sands. Here in Gulf, you see a lot of reclamation going on, whether it's palm or anything. It's all done in the sea, so it's a very common practice here. So all these things they have faced challenges here, and a lot of literature has been now written, like what happens if the carbonate content of the sand is much high. So CPTs do not perform the way it performs on normal silica sand. So a lot of correlations are developed, and sometimes we even give it to Norwegian and Geotechnical Institute to do a test to come out with some correlation. So there are a lot of things done to achieve this ground improvement to your satisfaction. So once this all thing is done in trials, then only they go into production phase where actually they just do it in a mass in full blown fashion. They do number of trials before going to the production phase. So these are the some many things which you will probably not learn here in classrooms, but this is how things happen in practice. So it's just to let you know that these things happen. Probably one small video to keep you. This is a site where dynamic compaction is going on. You see how the weight is lifted and a cater is formed there. So best of luck. I think I just made it in a time, slightly exceeded a little bit. So yes, you are the future, and whatever you decisions you make now, it does count. And best of luck. That's it from my side. Thank you.
Thank you, sir. Now, does anyone has any questions?
Yes, sir. So basically, I would like to say it was a wonderful presentation, especially the video. It was really interesting. So my question to you, sir, is like out of all the branches specialization, you chose geotechnical. So why is that?
Uh, it all depends on teachers, probably. I would say that when I was I was normal UG student with learning all subjects. Probably the geotechnical teacher inspired me most. Probably he made things interesting. It was probably when I started learning geotechnics, I felt maybe I selected the wrong subject, as you were saying. But later in life, I think I was very happy because I started my career with Engineers India Limited in Delhi. Probably the first 5 years, I was just doing typing and writing memos because those days it was not like emails and all those things. And doing photocopying for the seniors, and then just but being in the background and learning to discussions, and seeing that how much geotechnical participates in every discussion, which I was not thinking it was my cup of tea, but I used to see and I was getting impressed by the way the tender packages were developed in EIL. And then even with, I mean, I think I felt like that I am surrounded by a lot of known people, and I started enjoying that slowly. But yes, I had a second thought that why should I not, find out or continue the structures job. But now I'm happy because what I see that whatever decisions you take, it is counted, and it is very important, and you are a very key member in the whole group. It's like if something goes wrong with the structures, probably there is a fix available. If some member failed, probably you can add another member. What if piles fail? So that is why I saw that there is a lot of importance in this subject, and I started enjoying it slowly. But it is a challenge. It is not something like, I mean, you like a baller, you come and ball and you go away. You are like a wicket keeper. Every ball will come to you after every over. So yeah, this is tough. But yes, I started now enjoying it. It was a challenge when I probably took it as my career.
So like just another question, like what do you think? Like right now I'm just a second year civil student. So like after like graduation or something, like what are the skill set which would be like essential for me to be maybe might make me a good civil engineer or better in my field, for example.
Yeah, yeah. I mean, yes, I understand that you are very beginning of the career, and you have to decide. I would think that even if you are not doing masters in geotech and you want to have a job after civil and structural and you want to continue as that, you can do that. There is a good opportunity available even for civil structural engineers as such. But mind it, when you go for an interview, the first question will be on geotechniques. So concentrate on your soil mechanics and foundation engineering chapters, because most of the time it is geotechniques where people start the questioning for an interview. So concentrate on your whatever you're doing. You're doing steel structures. That's very fine. You do it. Concentrate on your dynamics part of structure engineering, because people do fail there in terms of knowledge, and because of lack of practice, not everybody gets an opportunity to follow dynamics, like learn machine foundations, and of course pay focus on how geotechnique is applied to your area, so that I'll give you an example. When I was in my previous company, it was decided that the geotech should be merged with civil and structure. There should not be a separate discipline for geotechnical engineer. Well said. So the department was dissolved, and we were merged with civil and structural engineers. The intention was not to dissolve geotechnics, but the intention was for structural engineers to not work in isolation, but to start learning geotechnics. And it was vice versa also true that geotechnical people should start doing the structural engineering. It went for 3 years or 4 years. All geotechnical engineers converted into structural engineers and with full knowledge of geotechnics, with not a single structural engineer having enough confidence to recommend anything on geotechnics. What happened that people did realize that this is what has happened, and geotechnical people started leaving the company because if you look at NOC and here, I think many guys who are here are basically a full complete package now because they are geotechnical guy who have now mastered the structural engineering as well. Whether it's onshore or offshore, anything, even for offshore jackets, platforms, etc., all these geotechnical engineers are running the software and going well into the. So there is a better scalability when it comes to having knowledge of geotechnics. So do concentrate on geotechnics. Don't just ignore because I understand it sounds very difficult in terms of taking decisions all the time. But at least whatever is specified in your course, learn that, and that will form the basic for your future. I hope that is okay for you.
Yes, sir. Thank you, sir.
Does anyone has any other questions?
My name is Alina, and I'm a third year student in civil engineering. So, I was wondering, how do you select a good master's program? Like, what do we look for in the colleges or the institutes? Do we look if they have a working situation there where we can directly apply what we are learning in the master's program into a company, or any other specifications?
I think the master's program as such would not vary in different colleges. I don't know. I'm not sure. I'm an old timer in this regard, but I would think that the course will not change. Probably what will impact is the thesis that you do in that your masters. If it is field oriented thesis or it is a numerical modeling type of an office thesis, this is where you will get interviewed, and this is where your salability in terms of job prospect would increase. Uh, and in addition to this, I think since you people are young, you should target getting chartered engineering courses and all those things. Even Hemant, who is here, had done this recently, in spite of getting old. But you should timely do it so that your college does not matter from where you have passed and all those things. Once you get chartered, this is what is sellable in the market at your age. So I would think that you should get these degrees and certifications wherever possible during your masters or after masters. You can register yourself as graduate engineer. I think there is a provision in ICE. You can do that and see the certifications that you can get, and that will give you a better sellability and control over the market and give an edge over the others.
Thank you, sir.
Sir, I just keep hearing like how structural engineers are like they are in more demand, or like if you want to do structure, it would be preferred you would take up structural engineering so you get more opportunity or something. So, like, what is your views about that?
It is quite true in the sense that that is why I gave an example of a wicketkeeper. In the team, wicketkeeper would be one, but there would be four bowlers and five bowlers and probably five batsmen with few of them all rounders. So yes, the job is not as much as easy that you get in structures, but mind it, if you are selected and you become Dhoni, you will become Dhoni. And then there is no comparison at all. So yeah, it's a difficult question in the sense that the job opportunities are much more for civil structure, but they would be abundant along with you for a competition as well. So if, I mean, in the recent 5 or 6 years, or even 7 years, 8 years, I would say that during this recession process, where many people are losing jobs, uh, then you will see that you have 10 more people around you, then you feel insecure. So probably I'm talking in terms of industry and how things are going on. But in terms of fetching job, yes, you will get it much more easily than a geotech engineer uh, with an let's say with a normal knowledge skills, not exceptional, but with the normal knowledge skills, you still have a better chance.
Thank you, sir.
Any more questions?
Yes. Hello, sir. This is Vivek here.
Hello, Vic.
Yeah. Sir, some small, it was a really, really interesting topic actually. And I'm a geotechnical engineer as well. So I enjoyed it mostly actually, I would say.
Okay, great.
And thank you for encouraging them to take geotech, mostly geotechnical engineering. And it's very difficult and tough to actually justify them. Like, yeah, as you said, it's a one wicket keeper and so many people actually around it. So
Correct.
it's as Seven sir rightly said, he is the captain of the team. And it will be because mostly depend on that. Yes, sir. Actually, I would extend my question to one something else. Like, say you were speaking about size-specific correlations, and you were sending that to NGI and all to for testing and all. Is there any course specific? Like, is there any course which is available in Dubai to give this kind of site-specific correlations and all?
Uh, well, this is a very good question in terms of you're talking about the reclamation and the ground improvement and
Yes.
carbonate content, right? Yes, there are papers available. There is no code available as such.
Okay.
Many researchers have done this exercise within Dubai as well
Mhm.
on calcareous versus silica sand behavior when it comes to verification process through CPT.
Mhm.
So what I have seen, the range is too wide actually. I mean,
Oh.
let's say I have specified a target cone resistance of 10 MPa as QC values. And when you actually, because I did all my liquefaction calculations and everything based on my silica based calculations.
Mhm.
So when people go in the field and they find that they're not getting more than 6 MPa, whatever they do, they have even tried a combination of ground improvement techniques, one over top of the other, but they can't go beyond that. So then when we looked into the literature and I found that the correlations do say from 1.2 times to even 2.4 times. So now the challenge is which one to pick out of this whole big range. So typically what I will do, I can tell in absence of any special test or anything like that, I typically restrict contractors to say that you will not allow use anything more than 1.6. So based on my experiences around this area. So this is what typically I recommend. So the 10 MPa target would come down to let's say 6 MPa. So that is what I typically do in this region.
Okay. Okay, sir.
But if you want site, it needs to be tested. And we did it for one site actually, where we sent it across and it was 1.8 or something, which actually motivated me to keep a target of 1.6 as my, baseline criteria.
Okay, okay, sir. Okay, sir. Regarding this, we have that performance-based design, probabilistic-based designs, and everything coming up. Do you consider that there will be that can be used for some judgment and some kind of judgment you can have to reach?
Yes, yes, I think everything is now allowed. I think even if you look at Eurocodes, it is even giving you based on observational method as well.
Yes.
So yes, yes, you can use them. Nobody stops you. Whatever you do, just if you're preparing a report or anything like that, where you are trying to justify that, just describe it properly. Whatever your assumptions are, what is your background, and I think that is it.
So
Nobody will challenge that.
it's so in India, it's very difficult to incorporate in this kind of things in the field. Like I understand, but in UA, it's allowed to actually use this and justify with the probabilistic analysis, performance-based analysis, and all kind of things.
Yeah, because I have not done too many Indian jobs, so maybe there's a gap here. Though I started my career within EIL, which was like nearly 10 years, more than 10 years, in fact, with onshore and offshore both. But those days, I knew that when we were doing offshore piling works, there whenever we encountered calcareous type of soil, but it was in Bombay High region, mostly it is clay and sand, but there is chances that you may hit a calcareous type of soil, but deep down. So
Okay.
we used to because that was not purely reclamation job, so it was not a decision maker or showstopper in terms of that. So, but here only when I started doing reclamation and ground improvement for the ports and terminals, there I started facing this particular significance of this carbonate content. And even in your normal pile design, I mean, Dr. Wade,
Yes.
even in your pile design, be careful when it comes to steel pile going through the carbonate sand. In fact, if next time, whenever we take it up next session, probably I would think to, you know, give something on piles actually, which there are a lot of challenges in piles itself.
Yes.
It's same like bearing capacity equation. I was trying to highlight that how real life scenario is different than what we are typically taught. So similarly in piles also there are so many things. Yes, we will definitely cover that. But thank you, Dr. Vivek.
Okay. Thank you. Actually, I would like to extend my discussion later. It's getting time. So yeah. Actually, thank you. Thank you for clarification.
Thank you, sir. Now, on behalf of
So
Skyline Association, I would like to thank Mr. Raj Tilak for taking his time to share his knowledge to enlighten us about the importance of geotechnical investigation for projects, new developments in soil investigation, ground improvements, and changes involved in offshore renewable energy projects, onshore projects. I'd also like to take this opportunity to thank HOD, Mr. Vivek, and Srilakshmi ma'am, faculty in charge and coordinator of Skyline Association, for their guidance and continued support, without which we'd not be able to conduct this session. My sincere gratitude to the faculties who have made time to be present with us today. Also to all members of Skyline for their kind contributions and unceasing support for helping organize this talk. And thank you all for being a wonderful audience, and we hope to see you again for our future webinars. Thank you all.
okay, thank you.
Thank you, sir.
Just